Hello students, in our last video we discussed some introductory part of matter. In that we discussed about intermolecular force of attraction, that is cohesion, and intermolecular space. Now we are going to discuss further means why we have different types of states and what are the properties of states one by one. This topic may contain 4 or more parts, but in every part you have to listen very carefully or see the video very carefully. Here I am using the very simplest way to guide you to clear your concept. I am not doing any experiment, not any animation, but with the help of my marker and board, I want to explain your concept. Let's start. As we know that in between two molecules of a matter, there is a space. That space is known as your intermolecular space. Intermolecular space. And also we know that two similar or different type of molecules attract each other, but in case of a particular matter they are same type of molecules, so same type of molecules attract each other. So this type of attraction, this type of force with which they attract each other, that is known as the intermolecular force of attraction. Though here we have same type of your molecules, so we can say force of cohesion or cohesion. Intermolecular force, or generally cohesion. Cohesion only in case of same type of molecule, of same matter or same element. Now, from these two factors, means intermolecular space and intermolecular force of attraction, on these two factors state of solid depend. Generally what happens, there are three conditions. First condition, force is stronger. I am giving the heading so that you can understand clearly. We have two factors, force and space. Now what happens? We know that there is intermolecular force, there force of attraction, there is intermolecular space. I am writing in brief so that you can easily understand and without wasting time. So if this force is stronger, in case of molecule, this force is stronger, then what happens? If this force is stronger, so it means molecules come closer to each other, so there is less amount of space in between them, means what? Intermolecular space is less. So it is your less amount. I discuss what state I have. Again, if this force is moderate or weaker, weaker is an easier word for you, but actually it's a moderate. Moderate means neither stronger nor neither large nor small, but at mid. So space between them is also moderate. Also moderate. Now if force is weakest, force is weaker or weakest or less, you can say negligible. There is no force between two molecules. Means what? If there is no force, so he is This molecule is unable to attack this one and this is unable to attack this one. So what happened? There is no effect of force of attraction of this molecule to this molecule and vice versa. So what happened? This go in its own direction and this go in its own direction. They are moving here and there randomly without the any effect of force, without feeling any attractive power from other. So if this is weakest, so space is larger. So there are three types of condition. So this is your space part, this is your force part. Now, if these two things have in any state of matter, so what happened? Molecules come closer to each other, there is no less space, so we are unable to move them likewise. So in this case, we are able to move or pull apart. This is the state of solid. In solid state, we have this property. And they are weaker. Force is weaker or moderate, so space is moderate. They move randomly. Particles move randomly within the boundary, that is your liquid. You know that liquid particles are free to move, but they not move too much. Weakest gas. You know the gas particles move away from the source and reach up to you, though you know that that source is far away from you. So this property come under gas. So I hope this part is clear to you, in which property, which type of force and which type of space is given in case of intermolecular space and force. Now we are going to discuss general properties of solid, liquid and gas one by one. In this video we discuss only the general properties of solid, so that we can clear the concept today itself, because you are observing this video today. So let's start. Okay, now we are going to discuss general properties of solid. Before we discuss general properties of solid, we know that in case of solid, force of intermolecular attraction, that is force of cohesion, is stronger. It means what? The molecules are tightly packed. Tightly packed means what? The intermolecular space is less or negligible in case of solid. So molecules are tightly packed. They are unable to move away from their places. They are fixed. Inside the solid, molecules are fixed. They cannot move away from each other. This is the property or behavior of solid molecules. Now, the very first point says that solid has a fixed point, fixed shape and fixed volume. The very first. Solid has fixed shape and volume. Fixed shape and volume. So how we discuss this one? As we know that in solid we have large intermolecular force of attraction and stronger intermolecular force of attraction and less amount of space is there. So as we know that molecules are closer to each other, they not move away from each other, so they have a unique shape. This is the reason that solid generally have fixed shape, and though they are tightly packed, they are unable to move away or expand from that one. Intermolecular force of attraction is stronger in solid, so molecules are fixed at their position, so their volume is also fixed. Means volume of any solid is also fixed one. This is the reason. Due to a strong force of attraction, we are unable to move, tear the bond. We are unable to separate them. That's why we have to cut the solid. We are unable to separate, but we can separate liquid and gases. Then our next point is Sorry. Solids generally cannot compress. Why solids cannot compress? Because we know that there is a less amount or no, there is a less or negligible space. That's why we are unable to compress the solid. Why we are unable? Because due to less amount space, less or no space, less or no space, we are unable to compress this one. And for this, it's such. This is due to stronger force. Now, next point says that solid does not flow. Solid does not flow. Why it does not flow? Because molecules are tightly packed, their position is fixed, they are unable to slip over each other. That's why solid particles or molecules or solid does not flow. So here we can write molecules are tightly packed. Molecules fixed at one position or unable to slip. Unable to slip. That's why solid does not flow. And the last part is a solid expands or contracts on heating or cooled. Why this thing happen? This will take little bit more time. Fourth one, expands on heating. First, expands on heating. If always remember that every state of matter expands on heating. In this case, while size of the solid expands when we heat it, because when we give heat energy to any piece of solid, what happens in that case? Solid particles receives that energy, become more excited, and if they are more excited, so they start to vibrate. They try to vibrate or move away from each other. They try to make some space. Suppose this part of molecules, this is a molecule, it receives energy from somewhere and it is tightly packed. This is the other energy. Now what happens? It starts to try to vibrate and frequently collide with this molecule. And due to this collision, this part also receives the energy and again it start to vibrate with each other, and they make some space within them. This is known as your intermolecular space, and with the effect of heating, the solid particles expand. And why they contract on cooling? Also, they contract on cooling. They contract on cooling. What? Just opposite to expansion. when we decrease the temperature of the particle, what happens? This energetic particle becomes less energetic and at last no energetic. And if this particle is no energetic, so also this one is also no energetic. So they come closer to each other. They come closer to each other and they come stuck with each other. Means they compressed their expansion. They decrease their expansion. These are the properties of solids. For showing this experiment, we have, for showing this two part, we have ring ball experiment. We have ring ball experiment. In that ring ball experiment, we are able to do this in a small scale of laboratory or in a home. But let me clear that in that, suppose we have a ring. This is a ring. Yeah, this is a ring, and we have a sphere whose diameter, this outer part, is equals to this inner part. Means ball can easily pass. Now what happened? We start to hit this ball so that ball can perform the expansion, and when after this hitting we try to move past this sphere from this ring. What you observe, ring is not heated, so ring is not perform the expansion, but suppose this is the ring, not perform the expansion, but we expand this ball, it performs the expansion, and when we try to pass this ball from this ring is unable to pass this expanded ball from the ring. That's why we can consider that there is a expansion in case of heating of the any type of matter. Similarly, just oppositely, we can show the cooling. Now this heat ball is unable to move. Now we keep this ball in ice cold water. It performs a compression and then it easily passes through the ring. This is the simple experiment. Read your book also, so to clear this concept. That's all for today. Thank you.